and welcome back to Algebra 1. Our goal for today is to continuing with factoring polynomial expressions completely. And more specifically, our very last review when you're given a quadrinomial or a trinomial to begin with, because we still have one type of polynomial we haven't looked at that we need to, which is what if you're given a binomial, which is a polynomial that only starts with two terms, which is a little bit different. We've only looked at how to do binomial problems that are linear. So how would we attack them if they were quadratic or higher? It's a little bit different because we have to think about our chart method also. So last little bit of review, I'm getting 4 terms or 3 terms. Can I factor completely? So at this point, we should understand that if we're given a what's called trinomial to begin with, right? It's a polynomial that has 3 individual terms. If the degree on that polynomial is 2 or higher, I must look for my GCF factor first, and then I must go to a quadrinomial in my chart and continue factoring from there. I'm not done until I've run all the checks for all that. Is there a GCF factor, and are there factors because of our chart method? So one last one here together, and then you're going to be working today in your notebook, so you're going to definitely want a loose piece of paper out if you don't already have it ready to go. Hit pause if you need to. All right, we want to factor that 7y to the second minus 13y minus 2. We want to factor it completely. All right, 7, negative 13, negative 2 don't have a common factor, so there's no GCF here. So we want to go straight to our guess and check chart. We have a positive 7 times a negative 2, which would give us negative 14 over here. And when we add them up, we need that middle amount of negative 13. All right, this is 1 away from 14. So I'm thinking 1 and 14 is my magic combo here. I need this to be a negative 13, and I need this to be a negative 14, which means one of these two has to be negative. And since I need this 13 to be negative, it would be the 14. If this was a positive 13, then the 1 would have to be the negative. Make sure you're getting the sign for the correct number. All right, we're going to break this negative 13y up. So we'll have a 7y squared. And instead of negative 13y, we're going to call it negative 14y plus 1. Or I can put a 1 in there, right? We're adding 1y. And then we have a subtract 2 term step. All right, we're ready for our chart now. 7y squared minus 14y plus 1y and minus 2. Row by row, column by column, let's pull out our greatest common factors. On the top, 7y squared and negative 14y both have a common factor of 7, and they at least have 1y. So we can pull out the greatest common factor of 7y. On the bottom, 1y and negative 2, all they share is a 1. So one of our factors down here would be 7y plus 1. All right, do the same thing with our column, 7y squared and 1y, and we'll end up with just a y, or 1y is what they have in common. All right, our star block here is negative, so bring it out automatically. All right, negative 14y and negative 2 have a common factor of negative 2. So our other factor here would be a y minus 2. So in this case, we end up with, we end up with a linear binomial factor of 7y plus 1 and a linear binomial factor of negative 2. All right, for the second part of class today, you are working on these problems. There's 6 of them. I'll expand my screen here so you can really see all of them. Hit pause here on the video. You're trying to factor completely all 6 problems. Once you're done, hit the pause button and resume, and really double check how well are you doing, because at this point we should be able to factor all of these with the greatest of ease based off of how much we've done these problems at this point. So take a second, hit the pause, try your best, factor them completely, proofread, double check, edit if you need in the end. All right, hopefully you have all 6 factored, so let's look at it. Number 1. I want to factor completely the GCF for the number 1 is a 16Q. Make sure you pull that out. And we'll have a q squared minus 3q plus 2 left over. We're going to then take this negative 3q and break it up into a minus 2q minus 1q. I have the plus negative versions, but you could obviously just have subtracting there. All right, row by row, column by column to get our factored version of 16q times q minus 1 times a q minus 2. Be careful way up here with this GCF factor. Make sure you have both a 16 and a q pulled out because they all have, right? This has a q, this has a q, this has a q. It's part of what they have in common, so be careful. All right, number 2, n squared plus 18n plus 81 does not have a GCF factor, so go straight to breaking it up into 9n and 9n. Row by row, column by column to get n plus 9 times an n plus 9, which means we can write it better as an n plus 9 to the second power. Look down here. You have 2 steps before you call it completely done because we can write this one better. All right, 4x squared minus 20x plus 25, again, does not have a common factor. So we're looking for things that multiply to give us 100 that would add up to negative 20, and it would be a negative 10x and a negative 10x. Again, I have the plus negative version. You might just have the subtract 10x version, which is perfectly fine. All right, row by row, column by column here, we end up with 2 factors of 2x minus 5. So again, down here we should have 2 steps, not just one, because we could write it better than as 2x minus 5 to the second power. All right, 4m to the third plus 10m squared minus 84m. Again, your GCF here, they share a 2 and an m because these all have at least one m. So double check your GCF. Make sure you pull both out. If you don't, you're going to have mistakes from there on, so be careful. All right, from there, we're looking for factors of negative 84 that give us that middle term of 5m, which would be a positive 12m and a negative 7m. Remember, these can be flip-flopped, or you can put the negative 7m first. That's okay, but those have to be your 2 middle terms there. All right, we get a factor of 2m, a factor of 2m minus 7, and a factor of m plus 6. All right, m squared plus m minus 30 does not have a greatest common factor, so we can go straight to, we need factors of negative 30 that add up to 1, which would be 6 and negative 5. From there, row by row, column by column, and we end up with m minus 5 times an m plus 6. Again, this might be listed first. This one might be listed second, depending on which order I put these 2 terms in. But as long as I have those 2 binomials, I have factored completely correctly. All right, last one. 15x squared minus 14x minus 8 does not have a greatest common factor. So we need factors of negative 120 that add up to a negative 14. Our magic combo then is a negative 20x and a positive 6x. Row by row, column by column, factor out our GCFs to get a binomial of 3x minus 4 and a binomial of 5x plus 2. All right, I hope that helps you attack your work for today. I will see you guys tomorrow.